In this video from ITFreeTraining, I will have a look at ISATAP. ISATAP is an IP6 transition technology. This technology is used to allow IP4 only and IP6 only networks to communicate with each other. ISATAP stands for Intra-site Automatic Tunnel Address Protocol. The first exam hint you should take away from this is the word intra. Intra meaning internal network. So ISATAP was essentially designed to work within a site or an internal network. This means it is not used for communication on the public internet. If you see an exam question on ISATAP, eliminate any answers that do not relate to internal use. ISATAP, put in the simplest way, connects an IP4 only network to an IP6 only network. To illustrate this, consider an IP4 only network and an IP6 only network. There is no common protocol between the two networks. However, if an ISATAP router is placed between the networks can now communicate with each other. ISATAP works as a bridge between the two networks. Let's have a look at how this is achieved. To achieve this, an IP4 node creates a tunnel to the ISATAP router. This tunnel is assigned an IP6 address. The IP6 address of the tunnel is broken down into two parts. The prefix part is provided by the administrator. This can be any valid IP6 prefix. This is used for routing on the IP6 network and to send data to the ISATAP router. The second part of the address is the interface ID. The interface ID has the IP4 address encapsulated in it. The interface always starts with the same hexadecimal sequence, followed by the IP4 address. When looking at the address, sometimes the IP4 part of the address will be shown as an IP4 address, and other times the address will be shown in hexadecimal. To understand the ISATAP transition technology, I will look at a different example. ISATAP uses tunneling to transfer data from the IP4 host to the ISATAP router. This essentially means that the IP6 packet is placed in an IP4 packet. To understand this, consider an IP4 only network with an IP4 only computer on it. This computer wants to communicate with a computer on the IP6 only network. To do this, the computer creates an IP6 packet. The computer, however, is not on an IP6 network, so in order to transmit the packet, the IP6 packet needs to be encased in an IP4 packet. In the next step, the packet is sent via an ISATAP tunnel to the ISATAP router. This example is a simple one, but the packet could have traveled over many IP4 routers to get to the ISATAP router. Once the packet reaches the ISATAP router, the IP4 packet is discarded, leaving the IP6 packet. This packet is then sent on the IP6 network to its destination. This is a simple example, but shows the basic process involved. I think you are ready for it, so let's look at a more difficult example which shows all the steps. In this example, a computer is connected to the IP4 network. The computer is allocated an IP4 address on this network. The computer wants to contact another computer which is on an IP6 only network with an IP6 address. There is no common protocol connecting both computers, so ISATAP will be used here to bridge both networks. In order to do this, the IP4 computer will allocate itself an IP6 address by contacting the ISATAP server. The first part of the address is the network prefix, which is configured by the administrator or obtained from the ISATAP server. The interface ID of the address starts with 5EFE, followed by the IP4 address of the computer. The computer now has an IP6 address. However, it is connected to an IP4 network. This is where the transition protocol comes into play. First of all, the computer needs to locate an ISATAP router. This is manually configured, but in this case the computer will contact a DNS server to obtain the address of the ISATAP router. The computer then creates an IP6 packet. Notice the source address is the address that is allocated to the computer using ISATAP, and the destination is the address of the IP6 computer. Since the computer is on an IP4 only network, the IP6 packet will be placed in an IP4 packet. Notice that the source IP address is the local computer's address and the destination address is the address of the ISATAP router. In order to contact the IP6 computer, the IP4 packet will be transmitted across the network. Since it is an IP4 packet, it will be routed like any other IP4 packet until it reaches the ISATAP router. When it reaches the ISATAP router, the IP4 packet is removed and the IP6 packet is routed to the destination like any other packet. If the IP6 computer wants to contact the IP4 computer, the process is simply reversed. You can see how the ISATAP process works, providing a bridge from IP4-only networks to IP6-only networks. However, remember that ISATAP is designed to work inside an organization on its private network. Thanks for watching this video on ISATAP. In the next video, I will look at what is required in order to set up and use ISATAP. Until that video, I would like to thank you for watching.